So here we're looking at basically part 2 of exponents, and we're going to talk about fraction exponents in this video. And I have a few just basic examples set up here. So if we have the square root of 8, that is rewritten as 8 to the 1/2. So you just rewrite it 8 to the 1/2. The cube root of 8, this 3 is called our index here, and that ends up being the bottom of our fraction. And so since there's nothing written in that first example, you just assume it's 2. A lot of times people call the symbol the square root, but really it's called a radical. It's only a square root if there's nothing written there, but we usually call it the radical symbol. So the square root of 2 to the 3rd, you can write as 2 to the 3/2. And then the 5th root of 16 to the 7th could be written as 16 to the 7/5. Now, one thing I haven't modeled the best for you here, and I should probably change this. You should get in the habit of writing 16 to the 7/5. Write your fraction as something over the other one, not with a sideways slash like that. It's just a lot less confusing to write it that way. Okay, so in general, if we have the nth root of a to the m, well, we kind of see what's going on here. We've got a to the m over n power. So this is how we handle fraction exponents. So if you have an exponent that is a fraction, you can write it as a radical. If you have a radical, you can write it as a fraction exponent. So what we're going to do is we're going to run through a handful of examples here, and we will talk about how we're going to handle this. The last example is going to be obviously the most challenging one of the bunch. And so let's start with a relatively basic one. So if we have 4 to the 3/2, once again, I should have written it like that. This is just saying we're doing the square root of 4 to the 3rd. So there's a couple different ways to approach this. I'll show you a second approach on part B here, but you can start by doing the square root of 4. And we know the square root of 4 is 2. So this would just be 2 to the 3rd, which is 8. And so that's one okay way to do this, is just to take the square root of 4, and that's 2. 2 to the 3rd is going to be 8. So on part B, if we have 27 to the 4/3, once again, I should have written my fractions like so. This is the cube root of 27 to the 4th. Now, another way to approach this, and this is maybe how you should start thinking about this, is it's the cube root of 27 is, when you see 27, you should see 3 to the 3rd. And eventually, as you do enough exponents, you will see 27. You'll say, oh, that's a power of 3. I know that right away. So that's 3 to the 3rd to the 4th power. And one of the properties we learned about in the first video is if you have 3 to the 3rd to the 4th, well, that's just 3 to the 12th. And then, like we've talked about in this notes video, is if you have the cube root, we can rewrite that as 3 to the 12th and then to the 1/3 power. And so the cube root is the same as the 1/3 power. And one of the properties we learned is if you have a power to a power, you just multiply those two things together. And so this ends up being 12 times 1/3 is 4. So it'd be 3 to the 4th, which is 81. So we started out with 27 to the 4/3, and that is the same as saying 81. It's just a really messed up way of writing the number 81. Okay, so that kind of guides you through what your thought process should be on a lot of these. You want to get it broken down to that the lowest base, and then use your exponent properties from there. So let's try the same thing here on part C. I'll switch up the colors so we can kind of see what difference between part B and C. So if I have 1/9 to the 5/2, that's the square root of 1/9 to the 5th. So one thing you can do, just like on the previous problem, is 1/9. You should see that as, let's see, we got the square root of 9 is 3 squared. So when you see 1/9, you should see that 9 is really 3 squared. Okay, and then we can use our power properties. 1 to the 5th is just 1, so we don't have to change that at all. And technically, I don't even need to write that 2 there. In fact, I'm going to stop doing that because you don't do that if it's square root. So 1 to the 5th is 1, and then 3 squared to the 5th is 3 to the 10th. And so if we're doing the square root of all of this stuff, then what we can do is rewrite it as a fraction. And so this would be 1 over 3 to the 10th to the 1/2 power. And then we can use the properties that we've learned. This 1/2 affects both the top and the bottom of this fraction. So 1 to the 1/2 is just 1. And then 3 to the 10th to the 1/2, when we multiply those, so we get 3 to the 5th, which is 243. So this would be 1 over 243. So that's our final broken down answer of 1/9 to the 5/2. All right. And so we got 2 left here. They're obviously getting progressively more challenging here. So this is the -3 over 2 power. So it's going to be a square root of 25 over 16 to the -3 power. All right. So this -3 power is going to affect both the top and the bottom. So I'm just going to rewrite that as 25 to the -3 over 16 to the -3. And one thing that you should be familiar with negative exponents is you always want to make those positive. And so one quick way to fix that is we are going to flip this and make them positive. And so the 25 to the -3 is going to go to the bottom, and the 16 to the -3 is going to go to the top. And you only flip it if they're both negative. If one of them's negative, you just bring that to the bottom or to the top, depending on where it's at. And so the square root of 16 to the 3rd over 25 to the 3rd. All right. And then there's a couple different paths we could take here. We could break it down to its common base, which is probably what, that's what we will do. Or you could take the square root of 16 and the square root of 25, and it's maybe a little bit quicker. But I want you to get in the habit of seeing these as like the simplest base. And so this is going to be the square root of 4 squared. 16 is 4 squared to the 3rd, and 25 is 5 squared, and then to the 3rd. And so this ends up being the square root of 4 squared to the 3rd is 4 to the 6th, and this would be 5 to the 6th. So this ends up being 4 to the 6th over 5 to the 6th, and since it's the square root, it's all to the 1/2 power. And then like we did on the previous example, that 1/2 power, whoops, hold on, there we go. That 1/2 power is going to affect both the 4 to the 6th and the 5 to the 6th. And so this ends up being 4 to the 3rd over 5 to the 3rd, which is 216 over 512. No, that's wrong. Way wrong. What am I doing? Back up here. 4 to the 3rd. Let's think about this. 4 times 4 is 16. 16 times 4 is 64. It's way off. And 5 times 5 is 25. Times 5 is 125. There, that's better. I don't know what I was thinking. I was thinking 8 to the 3rd and 6 to the 3rd. All right. So our last example here, it's going to get a little bit messy. And so we're going to do this in 2 parts here. We're going to break up, basically do that, and then we're going to also do the other part separate from that, and then we'll combine things at the end. So if we'd have 3 to the 4th x to the fourth, and then y squared to the fourth is going to be y to the eighth. And so that first part, you just take that 4 and multiply it to each exponent. And since 3 is to the first and x is to the first, it just becomes to the fourth power. All right. The other one, we've got kind of a mess going on here. We've got 9 x to the fourth y squared to the negative 3 over 2 power. But actually, we can do exactly what we did in that green part here, is we can multiply that into each part. And so this ends up being, I'm going to give myself a little bit more room here. So the green part's not going to change. This ends up being 9 to the negative 3 over 2. This would be x to the negative 12 over 2, because 4 times 3 is 12. And this would be y to the negative 6 over 2. All right. Well, 9 is 3 squared. So this is going to be 3 squared to the negative 3 over 2. This will be x to the negative 6 and y to the negative 3. And so this first part here ends up being, we do 2 times negative 3 over 2. So this is just going to be 3 to the negative 3. And then x to the negative 6 and y to the negative 3. Okay, let's bring this green stuff back down. We've got 3 to the fourth, x to the fourth, y to the eighth. Okay, one of these shortcuts that we learned on the previous video is if you have the same base and they're multiplied together, then you just add the exponents. And so if we have 3 to the fourth and 3 to the negative 3, that's going to be 3 to the 1. And the reason we add the exponents is we would have 3 to the fourth is like this. 3 to the negative 3 would be like that. You'd cancel out 3 3's, and you'd end up with 3 to the first on top. All right. If we have x to the fourth and x to the negative 6, we're going to have x to the negative 2. And then y to the eighth and y to the negative 3 is going to be y to the positive 5. And so we typically don't want to write them with negative exponents. And so this x to the negative 2 is going to go to the bottom. And we're going to end up with 3y to the fifth over x squared. So all of that mess ends up simplifying down to just that. All right, so that is the second installment of our exponent properties videos.